Hello students, in today's video I will be discussing two questions regarding joint probability distribution, and this would be the part 1 in this series. So in this first question, this particular question I'm talking about, the content is like the joint probability distribution of two random variables x and y is given by three statements, and these statements are probability at x equal to 0 and y equal to 1 is 1 by 3. Probability at x equal to 1 and y equal to minus 1 is 1 by 3. Probability at x equal to 1 and y equal to 1 is 1 by 3. Thereafter, we have to find here marginal distributions of random variable x and y and the conditional distribution of x given y equal to 1. Now, in order to deal with such question, first of all I will be discussing few basic details. Few number of concepts I am going to discuss here, some basic detail. So, if we are dealing with two random variables x and y are two random variables, and there will be two approaches as usual, discrete approach and the second is continuous approach. Whenever we are dealing with discrete approach, so x and y will be considered like discrete random variables, and whenever we are discussing the continuous aspect, in that way x and y are known as continuous random variables. So here the probability function fxy is known as the joint probability mass function. It is the joint probability mass function, or in short we may write it joint PMF. And for continuous approach, this fxy is known as joint probability density function. Joint probability density function, I mean to say, in short, it may be written as joint PDF. Now, thereafter, one term is denoted like marginal distributions. So, from this joint distribution data, so I am discussing here the joint data or joint probability function. As I discussed recently, that for discrete approach we are discussing joint PMF, and for continuous approach we are discussing joint PDF. Here this is fxy, and here also it is f of x y. Now what I want to say here, that how I am going to define the marginal distribution. So marginal distribution, this marginal distribution is just like separated into different variables. So if I am talking about g of x, that is summation y of fxy, and since summation is given, so we can utilize it like discrete approach. This g of x is marginal distribution of random variable x, and where this fxy is joint PMF. And this is the approach, discrete approach, and this is the approach which is continuous approach. Now the thing is like this is Gx in discrete approach. What about Gx in continuous approach? So that is minus infinite to infinite fxy dy. So it is, students, just like, again I will say, marginal distribution of what? Marginal distribution of x, but for continuous approach, and where this fxy is joint PDF. It is joint PDF. So these are very good to know formula. Gx for discrete and here Gx for continuous. Now thereafter I will be discussing h of y. H of y is the marginal distribution of random variable y. It is summation x fx y, where this hy is denoted as marginal distribution of y. Capital Y means here random variable, and this fxy is joint PMF. And if I will write hy in the continuous approach, so that is, students, minus infinite to infinite fxy dx. So here it is again, marginal distribution of y, and this fxy is joint PDF. So 4 formula I have discussed here regarding the marginal distribution. Now what I want to communicate next, that is about the conditional distribution. After marginal distribution we can be having knowledge of conditional distribution. So now if I will talk about conditional distribution, so conditional distribution, so how I can write it? I can write it in 2 ways. Fx given y is fxy upon g, not g, it is actually h, upon h of y. So this is fx given y. And if I will be talking about the next concept here, if y given x, that is fx y upon g of x. But 2 conditions are associated here. Here this hy is greater than 0, and here this gx is also greater than 0. So this fx given y is what? It is conditional distribution of what? It is conditional distribution of x given y, and this fxy is joint probability function, and this hy is what? It is marginal distribution of y, marginal distribution of y. Now thereafter this one is what? This is conditional distribution of y given x. It is joint probability function, and this is marginal distribution of x. So this is all about all the data, possible data about marginal and conditional distribution. So now in this particular video I started with this question. So in order to solve this question we required few basic data, so which I have already discussed here. So you may see here I have again written this, just cropped and pasted this particular uh, clip here. Now if I would like to make a table here for the values of x, so few values are given like 0, 1 and -1. So I will write -1, 0 and 1 for the value of x, and for this y what values I will be writing? I will be writing again -1, 0 and 1. So the thing is like this is the distribution for this joint probability function. It is actually joint PMF. It is actually joint PMF. Now this is given x is 0, y is 1 is 1 by 3. X is 0, y is 1 is 1 by 3. x1, y minus 1. x1, y minus 1 is also 1 by 3, and x1, y1. x1, y1 is also 1 by 3, and rest of the data here will be 0. Rest of the data will be 0, and this is g of x, this is h of y. Actually g of x is the sum of the column elements. So if we will sum up these column elements, it is 0, it is 1 by 3, and 1 by 3 plus 1 by 3 is 2 by 3, and hy is sum of the row elements. It is 1 by 3, it is 0, it is 2 by 3, and summing up this or summing up this, it will be always creating 1. Now if we will see this particular A part of the question, find marginal distribution of x. As I have given formula of marginal of x, that is g of x is summation y fx y, and here y is having values -1, 0 and 1. Y is just from -1 to 1. These integer values are there. So how I can expand it? I can write it if x -1 plus if x 0 plus if x 1. It is actually g of x, marginal distribution of x. But marginal distribution of x and y. Now thereafter it is the value of gx, but we have utilized here the value of y, as you can see, but we have not utilized the value of x. Now we will be utilizing the value of x. So x is also having 3 values. If you see here, x is also having 3 values. So I will be utilizing all these 3 values in this particular formula, and meanwhile we will be using this table as well. So if in this formula I am using g x equal to -1, so it is f -1 -1 plus f -1 0 plus f -1 comma 1. If I am using g, I mean to say x equal to 0, it is f0 minus 1 plus f0 0 plus f0 comma 1. If I am using x equal to 1 here, it is f1 minus 1 plus f1 comma 0 plus f1 comma 1. It is f1 minus 1, f1 0 and f1 1. Now we can add it. So f minus 1 is what? So we will check out this table now. F minus 1 minus 1. F minus 1 is 0 plus f minus 1 and 0 is again 0 plus f minus 1 and this 1, it is again 0. Totally it is 0. f0 minus 1, 0 and minus 1, 0 and minus 1 is 0 plus f0 0 is 0 and f0 1 is 1 by 3, that is total 1 by 3, and f1 minus 1 is 1 by 3 plus f1 0 is 0 plus f1 1 is 1 by 3, so total 2 by 3. So this is our verified result. As we can see here, g at minus 1 is 0. Yes, g at minus 1 is 0. G at 0, x equal to 0 is 1 by 3. Yes, it is 1 by 3. And g at 1 is 2 by 3. Yes, it is 2 by 3. So what I want to say here, whatever marginal distribution I have evaluated here, that is up to the mark. So how I can write the chart for marginal distribution? X was having 3 values, minus 1, 0 and 1, and thereafter if I say y is also have this not y, gx is also having 3 values, g of x is also having 3 values, that is 0, 1 by 3 and 2 by 3. So this is the chart for marginal distribution. This is the chart for marginal distribution of x. It is like this one. Now thereafter I am interested in finding the marginal distribution of y, this one. So we will be finding out that one, marginal distribution of y. Okay, so this was a marginal distribution of x. Now the next is marginal distribution of y. Marginal distribution of y, that is h of y is summation x of fxy as per the formula, and x is also going from minus 1 to 1, in between 0 is there. So that is h of y is f minus 1y plus f 0y plus f1 comma y. Now in this one, what we will do now, we will be utilizing the values of y. So y is also having 3 values, minus 1, 0 and 1. So in this formula we will utilize that. H minus 1, then h0, then h1. So what we will be getting, f minus 1 minus 1 plus f0 minus 1 plus f1 minus 1. Utilize here 0, f minus 1 0 plus f0 0 plus f1 0. Utilize here 1, f minus 1 1 plus f0 1 plus f1 comma 1. So if we will see from the table all these values, what we will be getting? We will be getting, now we can easily evaluate it from the table. We will be getting here these 3 values, 1 by 3, 0 and 2 by 3. So I will be writing that directly, 1 by 3, 1 by 3, 0 and 2 by 3. So these values we will be getting. I have already discussed in the marginal distribution of x. So now it is easy to understand that how to take these values. So how to write the chart for marginal distribution for y? How to write it? Just I will make it like this. Y is having three values, minus 1, 0 and 1, and h of y is just like this one, 1 by 3, 0 and 2 by 3. So this was all about marginal distribution of y. Now thereafter the B part of this question is, if I will say the B part of this question is like this one, the conditional distribution of x given y equal to 1. So how we can evaluate this particular thing? So let me discuss it. Conditional of x given y. I have given one formula here regarding the conditional distribution, and the formula was f of x given y is fxy upon h of y, fxy upon h of y. And in the question it is asked, we have to find f of conditional distribution of x given y where y is equal to 1. So I will fix it up. I will fix up here the value of y. So I mean to say, I want to get here this fx given 1, that is fx comma 1 upon h of 1. Now as usual we have fixed the values of y here, Now I will be taking the values of x one by one. So if I am taking x minus 1, 0 and 1, one after another, so I will be getting here f from this particular formula, f minus 1 given 1, then f0 given 1, then f1 given 1. So it is what? From this formula it is f minus 1 comma 1 upon h of 1. Here it is f0 1 upon h of 1, and it is f1 1 upon h of 1. So all these values, f minus 1 1 is what? If you see in the table, f minus 1 1 is 0, and upon h1, h of 1 here from we can get, this is the value of h1. So h1, 0 upon 2 by 3, ultimately it is 0. f01 from the table is 1 by 3, and upon h1 is 2 by 3. So it is 1 by 3 into 3 by 2, ultimately 1 by 2. And if I am saying f11 from the table is 1 by 3, and h1 is from the table is 2 by 3, so that is 1 by 3 into 3 by 2, that is 1 by 2. So three values we have got here. So I will now make the chart for this conditional distribution. How I can make the chart for this? This chart will be created for different values of x, because x is getting change here. So if I am writing three values of x here, that is minus 1, 0 and 1, and value of y is fixed. So this is what? This is f of x given 1. So when x is minus 1, when x is this minus 1, the value of here is 0. When x is 0, the value of this conditional distribution is 1 by 2, and when x is 1, then value of this conditional distribution is 1 by 2. So what I want to say, this is the chart for the conditional distribution. This is the chart for the conditional distribution, and that conditional distribution is f of x given 1. That's it. So this is all about this particular first question. I will recall that what I have done in this question. In this particular question, first I have evaluated the marginal distribution of x. So this was the chart for the marginal distribution of x. Thereafter what I evaluated? Thereafter I evaluated the marginal distribution for y and represented it by this chart. and after that I just evaluated the conditional distribution, and I have provided a chart for this conditional distribution. Now thereafter, in this particular video, I decided to discuss two questions, and this was the first question which I discussed. Now it is time for the second question. So let me paste this clip again. So here we will be getting here I'm going to paste this clip of second question. Now basics are clear, so easily the second question can be solved. Now in this question already this table is provided. Now students, what I want to say here, what is asked? So few parts are asked here. In the first part it is asked, find the probability of random variable x less than equal to 1 where y is equal to 2. It means what? It means if you see, x is taking values 0, 1 and 2, and y is taking values from 1 to 6. Here in this particular aspect y is fixed, but x is less than or equal to 1. So less than equal to 1 means 0 and 1, these two choices. How I can write it? Probability x is 0 and y is 2 plus probability x is 1 and y is 2. So x is 0 and y is 2. So what is this value? 0 and 2, this value is going to be this 0 plus probability x is 1 and y is 2. X is 1, y is 2 means this particular 1 by 16. So 0 plus 1 by 16 is going to be 1 by 16. So how easy is this now? Thereafter, if I will go for the second this part here, so that is probability of x less than or equal to 1. So in this particular question or part, nothing is mentioned about that one y. So probability x less than equal to 1 means probability at x equal to 0 plus probability at x equal to 1. So probability at x equal to 0 and probability at x equal to 1 means what? It is just like if I say at x equal to 0, what is the probability? So it will be the summation of all these values. This is probability at x equal to 0. So that will be 1 plus 2 3 plus 2 5 plus 3 8. That is 8 by 32. And plus, if I am saying probability at x equal to 1, it means it is summation of all these values. So it will be what? If I say 1 by 16 plus 1 by 16, so it will be 2 by 16, that is 1 by 8. So this is summation 1 by 8. So 1 by 8 how many times? 1 by 8, this will create 1 by 8. So 1, 2, 3, 4 and 5. So ultimately it will be 5 by 8. So let me check it once. Yes, it is right. So when we will be summing it up, it is 7 by 8. 7 by 8. So this second portion is also done. Now it's time for the third part. What is the third part? That is probability of y less than equal to 3. Now in this part, probability of y less than equal to 3 means nothing is mentioned about x. So probability of y equal to 1 plus probability of y at 2 plus probability of y at 3. Now probability of y, this random variable y at 1, it means summation of this column. Summation of this column, so I mean to say it is what? It is 1 by 16. It is just like I will say summation of this column will be 1 by 16 plus 1 by 32. So it is just like 3 by 32. It is 3 by 32. I can put it here. Plus summation of y equal to 2. So summation of this column, I mean to say, so 1 by 16 plus 1 by 32 is again 3 by 32 plus probability of y at 3 means summation of this particular column. So summation of this particular column means 1 by 32 plus 1 by 8 plus 1 by 64, or I can write it just 1 by 32, 1 plus 1 by 2 plus 1 by 8, or it is like 1 by 32 into 3 by 2 plus 1 by 8. So I think it is going to be 11 by 64. So you may verify it later as well. It is 11 by 64. So this calculation should be equal to 23 by 64. So it is like this one. Now thereafter, the last part of this particular question, that is going to be the D part, and that is what? Probability of x less than equal to 3 and as well as y is less than or equal to 4. Now here what we have to do, probability of x less than equal to 3 and y equal less than equal to 4, not equal, less than equal to 4, I can write it is like this one. If we try to understand, x is having the value 0, 1 and 2. So can I write it like, I mean to say, I will write it like probability of x equal to 0, y less than equal to 4, okay, plus I can write it probability of x equal to 1 comma y less than equal to 4 plus probability x equal to 2 and y less than or equal to 4. Now students, here our concept is quite clear now because basics are clear. Probability at x equal to 0, probability at x equal to 0 means at this one, at x equal to 0, but y is less than or equal to 4. It will be what? It means up to this particular value. So it will be like, I will write it like this, 1 by 32 plus this value plus this value plus 2 by 32 plus probability at x equal to 1 means at this particular value, but y is less than or equal to 4, I mean to say up to this value. So this will be what I will write here, summation of all these values, this and this. It is 1 by 16 plus 1 by 16 plus 1 by 8 plus 1 by 8, and the last value here will be probability at x equal to 2 but y is less than or equal to 4. So I mean to say the summation of these values, I mean to say these particular values. So it is just like 1 by 32, 1 by 32 plus 1 by 32 plus 1 by 64 plus 1 by 64, and all these values will be equated as 9 by 16. So students, as you can see, lot of knowledge is discussed in this particular video regarding the joint probability distribution. So one more time I am recalling it. Some basic details are given in discrete approach and in continuous approach. Thereafter, the next thing was marginal distribution in discrete approach and in continuous approach. After that, I just discussed here conditional distribution, and for that purpose I wrote there two formula, x given y and y given x. Thereafter, I started this particular first question, and lot of detail is discussed by me in this particular question, where few charts I created for marginal distributions for random variable x, and thereafter the chart was created for the marginal distribution of random variable y and after that I discussed the chart for the conditional distribution. This was there, and thereafter I discussed one more question, and in this particular question 4 parts regarding the probability were tackled. So students, I hope this particular video will help you a lot in this topic of joint probability distribution, marginal distribution and conditional distribution. Thank you so much for watching this video.